tree is? What's a factor tree? I mean, it's been a minute since you've probably used one. But what is a factor tree? What is it, Judah?
Is it a thing where you're trying to split a number up into twos and basically cutting it in half multiple times and going down?
Kind of. Not necessarily always twos. What is it? Right. It's a tree of factors. Get it? Factor tree. Tree of factors.
How many times?
You can split the thing and how many
Pretty much.
you
Yeah.
just keep splitting the
Keep going until you can no longer make any more factors. We don't put one, right? One does not become one of the factors. Okay. What's a prime number? What's a prime number? Kind of, Nora?
A number that's like you can multiply other numbers to get that number. Like
It's actually you can't.
oh, you can.
Right. What are the only two factors of a prime number?
One in itself.
One in itself. So we are breaking down a number until all we have left are prime numbers at the base of our tree. Okay, so let's just review. Let's say we have the number 48, right? The number 48. What can I multiply to make 48? And it doesn't matter which two I start out with, it will always end up with the same prime values. Christian?
24 and 2.
Sure. 24 and 2. Are either of those a prime number?
2.
2. So 2 is done. Can't do anything else with the number 2. That branch is done. I stopped there, right? What can I multiply to make 24? Brady?
6 and 4.
Sure. Are either of these a prime number?
No.
Nope. So this is going to keep going. How can I make 6? What can I multiply to make 6? And I'm not going to say 6 times 1. That's not what we're going for.
3 times
3 times 2. Raise your hand next time, Jordan. Okay. Are 3 or 2 a prime number?
4.
Yeah,
They both are.
I knew it.
What can I multiply to make 4?
2 and 2.
2 and 2. Right?
Raise your hand.
Are either of these prime numbers?
Yes.
They sure are. Okay. So part of today's lesson, simplifying radical expressions, is being able to do a factor tree. Can you guys do factor trees? Yeah. And then what you would do is you would look at all of these numbers at the end of your branches, and you would say, all right, I have 2 times 2 times 2 times 2 times 3. Okay, and it's important that you write them in order, least to greatest. It'll make sense in a second. Okay. Everybody with me? Yep, factor trees. So we're going to make one of these in our notes just as a refresher, especially since I started the video and whoever's watching the video, maybe Sophie, can't see a thing that we just did. Okay, so let's do a flashback. And we'll write the factor tree that we just created up on the board. So we started out with 48. And like I said, if we had done 6 times 8 or 16 times 3, we still would have ended up with the exact same 5 factors there at the end. Okay, so we did 24 times 2. 2 is a prime number. Then we broke down 24 into 6 times 4. Right? So that's what a factor tree does. It gives us all those prime factors. Notice none of those is a digit 1. Is 1 a prime number? It's actually called a special number, which sounds like really elite. It's just its own category. So it's not prime, it's not composite. What's a composite number? What's a composite number?
Like 48 or 24.
Sure.
The opposite.
48, 24, 6, 4, those are composite because they have other factors besides that number and 1. Right? So right now my son, I think I told you guys he made the math goal. Super geek, right? He's really excited. And he has to learn the first prime numbers through 100. He has to memorize those. That was his assignment last night. So we were both sitting at the kitchen table last night. You know when you're trying to think of something and you like look up and your eyes start kind of twitching? We were doing that last night, trying to recall all the prime numbers. Okay. So we know how to do a factor tree, right? So how does that, what does that have to do with a radical expression? Well, our radical expressions are also going to have variables, okay? And what we're looking for here are pairs of numbers, right? Do I have any pairs of numbers that match up there? What do I have, Grady?
4 twos.
I have 4 twos. How many pairs do I have?
2.
I have 2 pairs. It's really important that you keep in mind that a pair counts as 1, a pair counts as 1. And it's going to make sense when we get into the actual practice of simplifying, okay? So let's go ahead and we're going to start out simple. All right, we're just going to start out with a number that doesn't have variables yet. So we're going to simplify the radical expression square root of 150. Okay. Square root of 150. So we're going to make a factor tree of the number 150. Okay. So your factor tree might not match mine. You might be thinking 30 times 5. Maybe somebody else is thinking 50 times 3. Maybe someone's thinking 25 times 6. It doesn't matter what you start with. Okay? I'm going to do 25 times 6. Right? That would give me 150. Are either of those numbers prime?
No.
Nope. So I got to keep going with those branches. I can only make 5 times 5. These are prime. And then I can do 3 times 2. These are also prime. So now what I can do is I can rewrite the square root of 150 as 2 times 3 times 5 times 5. Right? I rewrote it. I did my factor tree. I rewrite it with all those numbers under the radical sign. Yes? I'm sorry? We're going to get there, so write them out separately for now, and it'll make sense in a second. Yes, Christian?
So I like the base prime numbers 2, 3, 5, 7, right?
2, 3, 5, 7, 11, 13.
We have like the ones that you mostly use.
Yes. Mm-hmm. Right? Okay, so here's where we're looking for pairs, right? I have a pair of 5s, okay? That pair would count as a single 5 outside the radical. I took this pair and I made a single 5 outside, okay?
What do you mean by that?
So, how do I put this? So this is equal to 25, right? So if I take the square root of 25, I get 5. So that's how I get a single 5 on the outside. So each pair counts as one of those digits outside, right? I used to tell this story about like you're at a party and you want to leave, so you find a friend and you go together in one car, right? So you and your friend get in one car to leave, okay? So what is left underneath here? What's 2 times 3? 6. So this would be my final answer. So the square root of 150 simplified as a radical expression is 5 square root 6. Right? So that is telling somebody my original number started out as 5 times 5 times 6. That's what that is telling us. 5 times 5 times 6 would give me the 150. Okay, Ethan?
So you're saying is like 6. So you do 6 times 6, and you just put 30, get rid of the square root sign. You
Nope.
Put 5 down there.
Not how it works. Nope. You cannot do that. You have to just do the prime numbers, and then you take the 1 out, 2 people, 1 car, and then everybody else is at the party, hanging out,
6 people at the party.
maybe. Right? Okay? Let's try another one.
This is crazy.
Let's do the number
300.
let's do 36.
36.
The number 36. What's special about this number?
They're both divided evenly.
It's a perfect square, right? So what's the square root of 36 going to be?
6.
6. Did I have to do a factor tree for that? Nope. Okay. Let's try another one. Let's try.
100.
No, because that would just be 10.
123.
No, we can't do anything with that. It's a prime number.
125.
No. Trying to think of a good one. Let's do 72. Square root of 72.
What is the square root?
So let's go ahead and do our factor tree. What two factors come to mind when you think of 72?
36.
Nora?
36
36 times
times 2.
2,
I'm so smart.
right? Somebody else might have said 12 times 6. Maybe you said 8 times 9. Doesn't matter what you start with. Okay? This 2 is a prime number. It stops. Then I have 6 times 6. Those are not prime numbers. So then I have 2 times 3 and 2 times 3 again. So I'm going to rewrite this as 2 times 2 times 2 times 3 times 3.
Does the smaller number have to be first?
Always do, yes, least to greatest. Yep, you want to have a system. Okay, so do I have any partners ready to leave the party? A pair of 2s and a pair of 3s. So I'm now going to have 2 times 3 square root 2 because I have the 2 times 3 on the outside. They came out, they each got in separate cars.
So they both gotta go up?
I'm sorry?
So they both gotta go up?
They both got to go. And so then I would say, all right, well that simplifies 2 times 3 is 6. 6 square root 2, that's my answer. And that's telling anybody that this started out as 6 times 6 times 2. And that's exactly what 72 is made of. 6 times 6 times 2. Okay? All right, I'm going to go on to my next page. You guys might have room. I do not. Now we're going to add some variables to this fun. So we have 12x squared. Okay, so first step, I'm going to do a factor tree of 12. Crew, what could I multiply to make 12?
2 and 6.
Sure. 2 and 6. 2 and 3. You could have done 3 and 4, and then you'd end up with 4 being broken down into 2. Yep. So now I have 2 times 2 times 3. But what about these x's? Well, what do you multiply to make x squared?
X.
So then you have to split those up into the single x's.
Okay.
Do we have any pairs?
2 and x and x.
Yep, the 2's are a pair, the x's are a pair. So my answer is going to be 2x square root 3. The 2 comes out as 1, the x comes out as 1.
Just one.
Yes,
Why is square root of it?
this should be square root of 12x squared, sorry. Just put that, it's gonna take you 2 seconds, just put it in there. Right? So, simplifying this radical expression, I do my factor tree, I write out all of my factors, including the variables. I find the pairs, put them on the outside. Whoever doesn't have a buddy is still inside. Not ready to go yet.
They want to stay at the party.
They're hanging out, they're living their best life. Square root of 88, m to the third, n to the fifth.
Prime number.
So we're going to make a factor tree of the number 88. You could do 11 and 8. What else could you do? 44 and 2. What else? 4 and 22, right? A lot of different things you can do. Okay, so I'm going to do 11 and 8 because I just feel like the number 11 gets ignored a lot. 11 is a prime number, so it stops right there. 2 and 4. 2 and 2. So now when I rewrite this, I'm going to need a long space to get all those m's and n's in there. Woo, barely fits. Now, eventually you'll be able to look and you'll be able to determine exactly how many m's and n's need to come out and what will be left over. Because what are you looking for if you're just looking at the exponent? You're looking for pairs. How many pairs can I make out of 3?
1,
How many pairs can I make out of 5?
2.
2, right? So eventually you will figure that out, and you won't have to write all of these out. But if you have any doubts, right, and you're like, I don't know, like, write it out. Yep.
Such a good line.
Do you know I was gonna say that?
I was just.
Have you ever heard that phrase before? When in doubt, write it out.
Just came to mind.
Which is natural brilliance. Okay, so we have a pair of 2's that will come out. We have a pair of m's. And we have 2 pairs of n's. So what that's going to look like is 2, we have 1 pair of m's, and we have 2 pairs of n's. And then what we're left with is 22, because 2 times 11, mn. So I have this 2, I have this m, and then I was able to make 2 pairs of n's, so that's why it's n squared. Everything else is left in there.
This makes sense.
How are we feeling about simplifying radical expressions?
Very easy.
It's not too bad, huh?
Yeah, it's easy. It's like
Yeah. Seems a little overwhelming, and then you're like, oh, Mrs. Marsh, this is for beginners. This is for beginners. Okay, let's try another one.
Is that a negative?
It is a negative.
Oh,
Okay? So the first thing I'm going to tell you is ignore this. Ignore the negative until the answer. Ignore the negative until you have the answer. Because we're literally just going to put the negative back with the answer. So it's not important until we're done, and then it's part of our final answer. So I'm going to start out with factor treeing the number 20. I would do 5 times 4. 5 is a prime number. 4 can be made into 2 times 2. So then with my radical, I'm going to have 2 times 2 times 5 times m times t times t times t times t. Oops, you guys can't see all those. There we go. So I have a pair of 2's that can come out, and I have a couple pairs of t's. So my answer is going to be what? Yep. 2t squared square root. And I've got that lonely 5m. And then I'm going to take my negative and I'm going to put it right here with the answer. Right, the negative goes right there with the answer. Okay, last example. Yep, negative 85, r to the 12th, m to the 9th.
A lot of numbers. 85
Yep.
85 divided by 5.
What do you notice about the 5 and the 17? They're both prime numbers.
Perfect.
So I'm not going to take the time to write out all of those r's because I know that 12 is divisible by 2. So I'm just going to show that I have 5 times 17 times r to the 12th times m to the 9th. So can I take out the 5 or the 17?
No.
Nope. So those are going to stay under there. So I'm still going to have this beautiful 85 here. How many pairs of r's do I have? 6. And how many pairs of m's do I have? 4, right? Because m to the 8th would be 4. So what I'm left with is 85m. And then don't forget this negative sign. Did you forget the negative sign? Rookie. Rookie.
I put them next. I told you to put them.
Okay, questions. Not as bad, right? All right, so now I'm going to pass out this. Guys, I will not be here tomorrow.
Second seat of it.
My boys have a dentist appointment, and I'm sure you guys all can agree that dentist appointments are impossible to get. And I know a lot of people would ask a teacher, well, why don't you just do it over a break? Well, it started out over break. Do you guys know how insurance works? Like, it has to be a year and a day or 6 months and a day when you can go back, right? So my boys, I had it down, winter break, fall break, spring break, all the appointments. But every time you go back, you have to push it back a day and hope there's something available after when you can come back. So now we're to January. Eventually, their appointment will be over spring break again, right? So they have a dentist appointment tomorrow. Also, I don't know if you guys, if I've told you yet, but I'm donating my hair. I told you that.
Yeah.
So tomorrow I'm going to get my hair cut. So Monday it should look slightly different. Short. So I found a place that will take 8 inches. So it's gonna be a little different. Yeah. Yeah, it's gonna be short. It's gonna be drastic, but I always said I wanted to do it at least once, so here we go. So that's my day tomorrow. Your day tomorrow is going to be working on this page, which I'm gonna pass out right now, so you can get a head start on it. And then the back of that exponent page, okay? I put the back answer keys up here. So while you're working through it, you can come check your answer. These have negatives, right? If you don't remember what to do with negative exponents, you're gonna wanna go back and look in your notes, okay? She took very specific notes on what to do with negative you guys are doing tomorrow.
Well, we finished it.
I'm gonna pass this out.
Are you gonna finish